Let us find reactions. Since it is a symmetric beam, so reaction here will be 20, here also it will be 20. Let us draw the bending moment diagram. This will be the bending moment diagram. And here it is 20 into 2, that is 40. Here also it will be 20 into 2, that is 40. Divided by EI, it becomes a curvature diagram. This is 2 meters. Midpoint it is 1 meter and 1 meter, and this is 2 meters. We know that the deflection of the beam is in this way, where maximum deflection is at midpoint. For tangent here, then slope is 0. Slope at O is 0. Slope here is theta A. To find the slope at A, let us apply moment area theorem 1. Moment area theorem 1, that is the difference in slope between A and 0, theta between A and 0 is equal to area between A and 0 of the curvature diagram. So it is theta A minus theta at O is 0 equal to area is half base into height for triangle, and for rectangle it is 40 by EI into 1, from which theta A is obtained to be 80 by EI, since theta at O is 0. To find the deflection at O, that is the maximum deflection, if we draw a tangent at O and applying moment area theorem 2, slope deflection at O will be moment of AO portion of curvature diagram about A. Since we draw a tangent at O and we took moments about A, that is half base into 40 by EI into 2/3 of 2 is the CG distance of the triangle about A, plus rectangle 40 by EI into 1 into CG distance is 2 plus 1 by 2. On substituting, we obtain it to be 460 by 3 EI. Now to find the deflection at B, this is the load and this is the load, 20 kilonewtons and 20 kilonewtons. A and D reaction is 20, here it is 20. We know the deflected shape. Let us draw a tangent at A and taking moments about B, we get this deviation. Let us say it is T BA, and this is theta A and this is 2 meters. So the total deflection is, say, delta. So our required deflection at B will be delta minus TBA, where delta equal to theta A into 2, which is 80 by EI into 2 80 by EI into 2, it is 160 by EI. To find TBA, that is moment of AB portion of curvature diagram, about B, that is half of base into height into CG distance is 1/3 of base, which will be 80 by 3 EI. So the final deflection at B will be 160 by EI minus 80 by 3 EI, which is 400 by EI, 400 by 3 EI. So we need to find slope, vertical deflection at B and midspan. Slope is this, vertical deflection at midspan is this, and at B is this.